Hello, today we are going to talk about another sorting technique which is commonly used, and it is called exchange or bubble sort. Either name refers to the same technique. So the steps for the exchange or bubble sort are very simple. Given a set of values, we compare the first and the second values, and then we decide whether or not they are in order with respect with each other. If they are not, then we swap them. And then we repeat these steps, but instead of comparing the first and the second value, now we compare the second and the third value. And again, if they are out of order with respect to each other, we're going to swap them, and then we compare the third one with the fourth one with the fifth one, so on and so forth. We are comparing two adjacent values at a time, and the idea is that by doing the swaps, the largest value will end up on the rightmost position of our data structure, in this case an array. So let's do an example with the numbers that you see here on the screen. So they are in random order, and our task is to sort them in increasing order. So the first step is to compare the first one with the second one, okay, 29 and 10, and they happens to be out of order because 10 is less than 29. So I'm going to swap those two numbers, okay? The rest of the numbers in my array or my collection are going to be ignored for the time being. So those stay the same, all right? Then the next step is going to be comparing the second with the third one, 29 and 14. And obviously those are out of order with respect to each other, so I need to swap them. So now 10 stays in the same place where it was before, and I'm swapping 29 and 14. And again, the rest of the values remain the same. Next is compare the second with the third one. And in this case, we notice that 29 and 37 are in order with respect to each other. 37 is larger than 29. So in this case, we don't need to do any swaps. Finally, we compare then the last two values, which are 37 and 13, and those two, again, are not in order with respect to each other, so we need to swap them. So I'm going to copy the first three values. They don't change their position, and then I'm going to swap 37 and 13. Okay? There are no more values in my collection. Of course, this is a very small collection, and we always need to think about big data, big size of data. In other terms, think about doing this technique for 5,000, 10,000, 100,000 values. Okay, so it's not going to be that obvious. But if you apply this technique, it's guaranteed that at the end of this process, you're going to have one number, in this case the largest, 37, in the correct position, which is the last one, if we are sorting in increasing order. The steps that we follow is called a first pass. It's a full application of the entire algorithm for this exchange or bubble sort. Obviously, the numbers are not all sorted, so we need to perform a second path, a second full iteration of the algorithm. So I'm going to start that on my next page. And so these are the numbers that we have so far. In order to sort the remaining unsorted numbers, the unsorted values, I need to perform a second path. In other words, repeat the entire process for the numbers, the values which are not sorted. So I'm going to copy the current state of the data, and then we are going to repeat the process as we have it. In other words, we're going to compare the first and the second number, and we realize that those two are in order with respect to each other. Then we're going to compare the second and the third one, 14 with 29. Those two are also in increasing order with respect to each other. And then we compare the next two adjacent values, which are 29 and 13. Those are not in order with respect to each other, so we need to swap them. So here I'm going to copy 10, 14, and I'm going to swap 29 and 13, and of course 37 okay, was already in its correct position. And this is the end of the second path. And at the end of the second path, now I have a new number, 29, which is in its correct position. And because it's a second path, now I have two numbers which are in the order that I want, okay? Then what do I need to do? I need to perform a third pass, repeat this technique for the third time, okay, to sort those numbers. So in this case, I'm going to consider, okay, these numbers, okay, and I'm going to worry only about the first one. So these two are already in order, okay, these two are not, okay, so 10 stays where it is, and I need to swap 13 and 14, okay, so I'm going to put 13 and 14, and I don't need to worry about 29 and 37 because they are already in order. So now, end of the third pass, I have now three numbers, as you can see, in the correct position. As it happens, the whole thing is already sorted, but the technique doesn't recognize that the first two numbers, in this case 10 and 13, are sorted. So I need to perform the algorithm for a fourth time to go through a fourth pass, and then it's going to realize that it doesn't need to make any changes. Okay? So that's the technique essentially for the exchange sort. So doing some analysis, we realize that in order to sort, okay, n values, we need to perform the technique n-1 times. We need n-1 passes, okay? We started with 5 values. We needed to go through 4 passes. Every pass is going to compare all adjacent values with the exception of 1. Compares 2 at a time, so that's n-1 comparisons. So n-1 times i-1, the approximation is n squared. So we said that the expected running time of the exchange or bubble sort is n squared, and that's why this technique is one of the one so-called quadratic sorts, because the expected running time is proportional to the square of the size of the data. Don't worry about what this O, big O notation means. We're going to talk about this in a different video. It's just simply a notation we use in computer science. The thing to understand is that this tells us that this is a very slow technique, because if you have 10,000 elements, the square of 10,000 is pretty big, so the expected running time is going to take a lot. All right, so now let's do something a little bit different. What if we have a different set of values which are, for example, in order? So look at the values that we have, and we quickly visually realize that these are already sorted. Now, the algorithm doesn't know that, so the algorithm is going to start by doing the same series of steps, which is compare the first two. They are not out of order, they are already sorted, so it says no swaps. Okay, compare the next two, no swaps, compare the next two, no swaps, compare the next two, no swaps, and then it says, okay, then the last value must be the largest, and indeed 61 is the largest. So the first pass didn't require any swaps, but it did compare all the elements in pairs. What's going to happen? Well, the algorithm again doesn't know that the values are already sorted because we didn't perform any swaps. What it's going to do is going to say, all right, I need to now take care of these 4 values. And it's going to again compare these 2, and then these 2, and so on and so forth, and then realize, oh, 49 is in the correct position. So no swaps again. So at the end of the second path, we still have the same result that we had before. And this is going to do it a third time, and it's going to do it a fourth time. In other words, it doesn't matter what the state of the data is in the exchange or bubble sort, we are going to require the same numbers of passes, which is n-1, and the same numbers of comparisons, which is n-1. So even when we didn't perform any swaps, the expected running time remains the same. So let's do now some basic analysis of the exchange or bubble sort. Every iteration of this technique may result in more than one value in its correct position. It's guaranteed that at least one value will end up in the correct position, but as you saw, more than one may end up in the correct position. Second, every pass or every iteration may swap more than two values. So this is a technique that requires a lot of swapping values. And finally, in order to sort n number of values, random values, we're going to require n-1 iterations, which means this is a quadratic sort. If you haven't watched the video in the ExchangeSort, probably you should, because that's another quadratic sort. Also, InsertionSort is another quadratic sort. So you should watch all three videos and then try to compare the three different techniques.